okay? And so we're going to be finding the value of x when it's on a sine curve, cosine curve, tangent curve, all of that. The one thing you have to remember, what is the period of a sine and cosine? 2 pi. And then after every 2 pi, it redoes our curve, right? The exact same. What is the period for a tangent curve? What's the period for a tangent curve? Remember, we have those vertical asymptotes, right? And where do we have those vertical asymptotes? At negative pi over 2 and positive pi over 2, right? So from negative pi over 2 to pi over 2 is how many actual units? Negative pi over 2 to pi over 2? Isn't that just pi units? Just pi units, okay? So when we look for the actual values, we're going to look for answers in the intervals of 0 to 2 pi for sine and cosine, and from 0 to pi for tangents, okay? But however, we know our curve keeps on continuing every time, right? So when we're looking at sine and cosine, after we find our solutions, we need to add on 2n times pi, right? Because if I go another term, we add on another 2 pi, right? So it keeps continuing from that. And for tangent, it's just going to be n times pi, okay? So that will include everything within our sine curve because it is a continuous curve. Now, if it just says between the interval of 0 and 2 pi, would I have to add these on to my solutions? No, because we know we have a limit on when my answers have to be, okay? All right, so we're going to solve these just like normal equations. We want to find when sine x equals something, okay? So if we're solving sine x plus radical 2 equals negative sine x, we need to combine our signs, right? So how would I move the negative sine x to the other side? When I add it. So we're looking at these trig functions as our variables. So if I had x plus x, what would we get? What's x plus x? 2x. So if I have sine x plus sine x, isn't that just the same thing as 2 sine x plus radical 2 equals 0? Now, we need to solve just for the sine of x. So if this just read 2x plus radical 2 equals 0, how do I solve for x? What would be my first step? Subtract the radical 2, right? So when I have 2 sine x equals negative radical 2, yep. And then how would I get rid of the coefficient of 2? I would divide it, right? So divide by 2. So we know the sine of x equals negative radical 2 over 2. So now we actually need to figure out where is negative radical 2 over 2. Okay, so think of this for a second. If you have your chart from the 4.4, isn't it 4.4? When we have radical 2 over 2, isn't that just pi over 4? Isn't that a 45, 45, 90 triangle? However, this is negative, right? So what quadrants is sine negative? One is 3 and 4, right? Quadrant 3 and 4. So if we're looking at our coordinate plane, okay, our sine is going to be negative here and here, right? So where is this? This part here is what over 4? Isn't that 5 pi over 4? And where would it all the way down to? Quadrant 4. Wouldn't that be 7 pi over 4? Because we always want to look for our sine in between the interval of 0 and 2 pi, right? So is it 5 pi over 4 between 0 and 2 pi and 7 pi over 4? And wouldn't those both give me values of a negative sign? Yeah. So these would be the solutions of x if we were looking for the interval of 0 and 2 pi. But because we want to include every single solution, the general solution is where you're going to add the 2n pi to every single one of our answers. Okay. So my solution would be, the general solution is 5 pi over 4 plus 2n pi, and 7 pi over 4 plus 2n pi. So no matter what, how many times we keep following our sine curve, we add 2 pi to each one of these, it's going to keep giving us a solution when the sine of x is negative radical 2 over 2. Okay? Does that make sense to you guys? Okay. All right. Let's look at the next one. Solve 3 tangent x minus 1 equals 0. What do you think my first thing would be to solve for that tangent of x? Add 1. Yep. So we get 3 tangent squared x equals a positive 1. And then what? Divide by 3. So we get the tangent squared x equals 1/3. Right? And then what? Take the square root. So we get the tangent of x equals, now I'm taking the square root, so how many answers do I have? 2, so I need to have the plus or minus the square root of 1, which is 1 over the square root of 3, right? Can I have the square root in the denominator? No. So we would rationalize it, right? So the tangent of x is going to equal plus or minus the square root of 3 over 3. Now, we can have positive and negative, right? Because remember, our interval for tangent is between technically really negative pi over 2 and a positive pi over 2, right? Okay. So now, where do we have a radical 3 over 3? That is that a 45, 40, 90 triangle or a 30, 60, 90 triangle? It's a 30, 60, 90 triangle, right? And where do we have radical 3 over 3? That is that pi over 3 or pi over 6? Pi over 3 would be your 60 degrees, right? Pi over 6 would be our 30 degrees. So where do we have the tangent of radical 3 over 3? Is that pi over 6 or pi over 3? It is pi over 6. So we know x would equal pi over 6. And that would take care of our positive radical 3 over 3, right? So where would our negative be? At what? Wouldn't that be at a 5 pi over 6? Is that right? Quadrant 1 and quadrant 2 gives you the negative, right? Okay. So now, because this is our actual solutions where we have both of these, okay, the general solution is, what do we add to each of those? Is it 2n pi or just n pi? N pi, why? Exactly, our tangent interval is just pi. And there you go, there's your 2 general forms. So do you see why actually memorizing things probably would have helped a little bit more? Yeah. All right. All right, so looking at here, cotangent x times the cosine squared x equals 2 times the cotangent x. What do you guys think you're going to have to do with this first? Huh? Move the cotangent over. And how would I move 2 cotangent x over? Subtract it. Perfect. So we have cotangent x times cosine squared x minus 2 times the cotangent of x equals 0. Now what would we do? What do you think would we do here? Not square root yet. What do we do? If we have an x squared, what do we always try to do to solve for x squareds? Can we try to factor it? Could I solve by factoring whenever I have x squareds? Yeah. So if I look at this, can I factor anything out of these two? Cotangent. Can't I factor out a cotangent? So if I factor out a cotangent from cotangent x, cosine squared x, don't I just get the cosine squared x? Oops, minus, sorry. And if I take a cotangent out of 2 times the cotangent, aren't I left with just minus 2 equals 0? You guys okay with that? Now, once we're in factor form, what do I do? Think about this. If I had something like x plus 2 times x minus 3 equals 0, how would you solve these? Set them equal to 0. So guess what we're going to do here? Set them equal to 0. So we have the cotangent of x equals 0. So cotangent, again, is between the interval of 0 and pi, right? When is the cotangent 0? When is the cotangent 0? So remember, cotangent is the opposite of the reciprocal of tangent, right? Tangent is sine over cosine, right, which is y over x. So the cotangent would be x over y, right? So when is, for me to get 0, it's when my x is 0, right? So when is my x 0? At pi over 2, right? Does that make sense? Because when we're looking at when this is 0 or like 1 or -1, isn't that on my actual quadrants? So when would I have x to be 0? Either at pi over 2 or 3 pi over 2, right? But because it's in between the interval 0 and pi, we know our x is just pi over 2, right? So we know this is just pi over 2. So in our general solution, it's cotangent. So what are we going to add to that? Is that 2n pi or n pi? N pi. Why? Because it is cotangent, which is the same as tangent, right? Just kind of flipped it. All right, let's solve cosine. How do I move the cosine or the 2 to the other side? Add it, right? So we get cosine squared x equals 2. And then what? Take the square root. So we get the cosine x equals the square root plus or minus the square root of 2. What is the square root of 2? Just wondering, what is the square root of 2 roughly? Is that 1 point something? Yeah, 1 point something. Yeah, 1.14. Because think of it, the square root of 1 is 1. The square root of 4 is 2. So the square root of 2 has to be in between those two, right? Okay. Think of our range. What is our range of a cosine? Goes between what two things? 1 and -1, or -1 and 1. Did the square root of 2 ever work in that? No. So this one actually here actually has no solution. And do we know exactly where the square root of 2 would be? Is that a pi over 4? Is that a pi over 2? No. Okay. Let's look at just plain quadratics. We did a quadratic one there with the cosine squared. Remember, quadratics are ax squared plus bx plus c, okay? The quadratic in a sine x is the same thing as like 2 sine squared x minus sine x minus 1 equals 0. So that could be a quadratic in sine. You could also see it as if they put the sign in parentheses and square it. That means the exact same thing, doesn't it? Minus sine x minus 1. So sometimes you might see sine squared or the quantity of sine squared. Those are going to be the exact same thing, right? Same thing with secant. So if you see like secant squared x minus 3 secant x minus 2 equals 0, we could put the secant x inside the parenthesis and square it. That means the exact same thing. 3 times secant x minus 2 equals 0. And again, same thing with cosines, all of that fun stuff. I just went ahead and did sine and secants. Now, if we see a sine squared or cosine squared or tangent squared, what should we always try to do? What's the first thing to solve quadratics? I would try to factor first. If you can't factor, what's another way? You could do square roots, which we already did on the first page, but what's another one? The formula, the quadratic. Is that what you're trying to get, Hannah? The quadratic formula or completing the square. I'm not going to complete the square. That makes it 10 times harder, I think. Okay, so we're going to try to factor, and if we can't factor, we have to use the quadratic formula. Okay, we've done solving by square roots already. That's part of quadratics and that kind of stuff, but this part is all using this kind of stuff. Now, to be able to factor, though, we need to either have all sines or all cosines, all tangents, things like that. So we still need to know our trig identities, right? Okay. Find all the solutions of 2 sine squared x minus sine x minus 1 equals 0 in the interval of 0 and 2 pi. Now, because we're given an interval, do we have to do the general solution where we have to add the 2 and pi? No, because we want it just between these two. So if they give us that interval, we do not have to add the 2 n pi or the n pi, okay? So if we see 2 sine squared x minus sine x minus 1, can I factor that? If I had 2x squared minus x minus 1, can I factor that? So if I had just 2x squared minus x minus 1 equals 0, can I factor this one? How do I get 2x squared? Wouldn't that just be 2x times x? How would I get a negative 1? 1 and 1, right? But I need one of them positive, one negative. Which one would add, if I go to multiply the outside and inside, which would add to a negative 1? The second one has to be negative. So can I factor that? Yes. So can I factor 2 sine squared x minus? Yes. The only difference, what changes to the 2x and the x? They become sines, right? So to factor this, I would have 2 sine x plus 1 times sine x minus 1 equals 0. Now, once we're factored, what can we do? Set them equal to 0. So we have 2 sine x plus 1 equals 0 and sine x minus 1 equals 0. So let's do this one first, because that's easy. How do I solve for the sine? Just add the 1, right? So sine x equals 1. So we know that's going to be on a axis, right? And sine is always the y coordinate. So when is your y coordinate equal to 1? Pi over 2. Is pi over 2 between the interval of 0 and 2 pi? Yes. So this would be one of my solutions. Okay. All right. How would I solve for the sine of x here? What would I do first? Subtract the 1, so I get 2 sine x equals negative 1. And then how do I get rid of the 2? Divide. So we get sine of x equals negative 1/2, right? So negative 1/2, is that a 30, 60, 90 triangle or a 45, 45, 90 triangle? Huh? 30, 60, 90, right? 30, 60, 90, 30, 60, 90. So we know this is going to be one of those 30, 60, 90s. Now, if it's 1/2, is it pi over 3 or would it be pi over 6? Would that be based off of the 30-degree angle or the 60-degree angle? What did you say, Andrew? It is the 30, right? So it's pi over 6. Okay. So now we know 1/2 is pi over 6. However, this is negative. So what quadrant would our negative 1/2 be our sign? Quadrant 3 and quadrant 4, right? Because isn't my y coordinates negative in that sense? So now, from here to here is pi. We need to add another 6, right? So what's pi plus 1/6? What's pi plus 1/6? Wouldn't that be 7 pi over 6? Okay, you guys okay with that? And then to get to this one in quadrant 4, we're really taking almost 2 pi, but subtracting pi over 6, right? Where would that put me? 11 pi over 6. Now, are both of these solutions between the interval of 0 and 2 pi? Yes. Would they both give me negative 1/2? Yes. So there's your other solutions. So there's all 3 of your solutions in this sense. Okay. So if you notice, we actually have more than just normally with the x squareds, we had a possible of 2, right? Now we actually have 3. All right. Example 5. 2 sine squared x plus 3 cosine x minus 3 equals 0. What's wrong with this? We have sines and cosines, right? But do we know something about sine squared x? Is sine squared x equal to something cosine? Think of your trig identities. What do we know about sine squared? It's one of your trig identities. Something with... Don't we know that sine squared plus cosine squared equals 1, right? So what would the sine squared equal? Sine squared would equal 1 minus cosine squared x. So could I replace sine squared with 1 minus cosine squared to get us to at least have cosines in my equation? Yeah, so let's go ahead and do that. So we have 2 times 1 minus cosine squared x plus 3 times the cosine x minus 3 equals 0. So now we have the same units, right, in my equation. What would I do first here? What do you think I would do before I could factor this? What would I have to do? I would have to distribute the 2. So I get 2 minus 2 cosine squared x plus 3 cosine x minus 3 equals 0. Now, do we have any like terms? Don't I have the 2 and the 3, negative 3? What's 2 minus 3? And then negative 1? 0. Now, can we factor this? Now, the only thing, do you see how this is a negative in the front here? Can I just change the sign of everything to make that a positive? Yeah. So I'm going to change that to a positive 2 sine or cosine squared x. Then my 3 becomes a negative 3 cosine x, and my 1 becomes a positive 1. Okay. Now, can you factor that? Aiden, do you see why I made that positive? Okay. Just gave me kind of a funny look, so I wasn't sure. Okay. All right, so let's go ahead and factor. So 2 is prime, so I know I'm going to have 2 cosine x on one of them. Isn't 1 also prime? So we know it's going to be 1 and 1. Now, are these going to be opposite signs, the same sign? The opposite or the same sign? Well, we have to multiply to be a positive 1. So they're going to be the same. And are they going to be positive ones or negative ones? They're going to be negatives, aren't they? Why? Because a negative times a negative is a positive. But when I add 2 negatives, won't they get me to a negative? Yes. Okay. Now, can we set these equal to 0 and solve? Yeah. So 2 cosine x minus 1 equals 0. The cosine of x minus 1 equals 0. Let's go ahead and do this one first. How do I move the 1 over? Got it. All right. So the cosine of x equals 1. So cosine is my x coordinate. So when is my x coordinate equal to 1? At 0. So this is equal to 0. Okay. Now, does it tell me an actual interval that I need to stay in between? So at 0, what am I going to have to do for my general solution? Add what? 2n pi. Do I need to have the 0 there? No. So we know at 0, we're going to have 0. It's going to be at 0. It's going to be at 2 pi. It's going to be at 3 pi. It's going to be at 4 pi, all of that, right? Sorry, so there's 1. All right, the other side. Solve for cosine. How would I move the 1 over? Add it, and then divide by 2. So I know the cosine is equal to 1/2. Okay. So the cosine is 1/2. So is this going to be a 30, 60, 90 or a 45, 45, 90? 30, 60, 90. Now, when it was sine of 1/2, we know it was pi over 6. So for cosine, it will be pi over 3, right? So now, real quick, when cosine is positive, what quadrants are we in? So the x coordinate has to be positive, right? So wouldn't we be in quadrant 1 and quadrant 4? Yeah, sorry, quadrant 4. I don't know why I wrote that. Quadrant 4. So quadrant 1, wouldn't that just be pi over 3? Yeah. So quadrant 4, right? Quadrant 4 would be 2 pi minus that pi over 3, which would put you at what? 2 pi is 6 pi over 3, right? So it's 6 pi over 3 minus 1 pi over 3. 5 pi over 3. Okay. So now, my general form, I take pi over 3 and add 2n pi, and then 5 pi over 3 plus 2n pi. And again, it doesn't matter, guys, if you put 2 pi n. I always keep wanting to do that. That's okay. That's the same thing. Okay. All right. Any questions so far? All right. Next one. Find all solutions of cosine x plus 1 equals sine x. Now, if you notice here, we have cosine and sine, but are any of those squared? No. So we can't convert any of that right now, can we? But if I do something to the left side, can I do the same thing to the right side and it's still going to keep equivalent? So I want to make sure, I want to somehow get sine to cosine or cosine to sine, right? So could I just square both sides and then I would have it squared? And if I square the left side, is it okay to square the right side and it's still going to be equivalent? Yeah, so let's go ahead and square both of these sides. And square and square. Sine x squared, that's the easiest one. That's going to be sine squared x, right? Now, if I want to square cosine x plus 1 and square it, don't I actually have to FOIL that out? Right, because cosine x plus 1 squared means cosine x plus 1 times cosine x plus 1. So I actually have to FOIL that, don't I? Yeah. So what's cosine times cosine? Cosine squared x. Cosine times 1 is cosine. What's cosine times 1? Cosine. So what's cosine plus cosine? 2 cosine, yeah. X. And then what's 1 times 1? 1. Okay. Now, hey guys, we have sine squared x. Do we know, can we change sine squared x to something cosine? Yeah, what is sine squared x equal to? Isn't that equal to 1 minus cosine squared x? Yeah. Now, are we able to move this stuff over to the other side and combine like terms? Yeah. How do I move this 1 over? Subtract it. And what happens to these 1s? Don't they cancel out? How do I move the cosine squared over? Add it, right? What's cosine squared x plus cosine squared x? 2 cosine squared x plus 2 cosine x equals 0. Now, from here, what would you guys do? We need a factor. So what is my GCF between 2 cosine squared and 2 cosine? 2 cosine. So I can take 2 cosine off, and I'm left with cosine plus what? 1, yep. And now, since we're factor, can we set each part equal to 0? Yeah. So we have 2 cosine x equals 0 and cosine x plus 1 equals 0. You guys okay with that? So now solving, the cosine of x is going to equal 0, right? And when is my cosine equal to 0? When is my x equal to 0? Pi over 2 and 3 pi over 2. Now, are both of these in between the interval of 0 and 2 pi? Yes, okay. So now let's keep going on this. We're not done yet, but subtract the 1, right? So when is my cosine negative 1? So when is my x negative 1? At pi. Is that in between? Yes. So right now, these are my solutions. But because we squared both sides, when you square things, don't we kind of get some kind of extraneous solution sometimes? Yeah. So anytime you square both sides, you need to check for extraneous solutions. And what are extraneous solutions? What are extraneous solutions? It's when they appear to be a solution, but if I plug it back to the original, it is not actually true, right? So could I plug in each one of these, and you can even use your calculator in that set, and see which one doesn't make the left side equal to the right side? So go ahead and do that real quick. Go ahead and use your calculator if you want to. Okay. So as you plug in, you guys will find out that pi over 2 works, pi works, but 3 pi over 2 does not work. Okay. think about this. Okay, 3 pi over 2. The cosine of 3 pi over 2 is what? The cosine of 3 pi over 2 is actually 0, right? Sorry, no. 3 pi over 2 is 0. 0 plus 1 is what? 1. But what's the sine of 3 pi over 2? Isn't that negative 1? Isn't the sine of 3 pi over 2 negative 1? Yeah. So does 1 equal negative 1? No. So that's why 3 pi over 2 is not. Okay. You can also think of it as a coordinate plane. Okay. So again, at pi over 2, let's start with pi over 2. We know that coordinate is what? 0, 1, right? So the cosine of pi over 2 is 0. 0 plus 1 is 1. Is the sine of pi over 2 1? Yes, because that's your y coordinate. So that's why we know that one works. 3 pi over 2 is at 0, negative 1. So the cosine is 0 plus 1 is 1, but the sine of it is negative 1. 1 does not equal negative 1. That's why that one's an extraneous solution. At pi, my coordinate is negative 1, 0. Okay, so cosine of pi is negative 1. Negative 1 plus 1 is 0, and the sine of pi is 0. So we know that one also works. So that's why these two work, but 3 pi over 2 did not work. So anytime you square it, you need to make sure you check for those extraneous solutions. Okay? That's what I keep saying. Memorization is really key in these. It helps a little bit. All right. Solve 2 times the cosine of 3t minus 1 equals 0. So if you notice here, okay, we have this 3 times that angle, right? The x. We're going to solve it exactly what we did before, okay? So let's go ahead and solve for the cosine of 3t. So what would be my first step? Plus the 1. Yep, add the 1. So the cosine of 3t equals 1. And then how do I get rid of the 2? Okay. So the cosine of 3t equals 1/2. So we're going to treat this kind of like the cosine of 1/2. Okay. So when is my cosine equal to a positive 1/2? So positive 1/2, is that going to be a 30, 60, 90 or 45, 45, 90? 30, 60, 90. And because the cosine is 1/2, that is, are we using the 30-degree angle or the 60-degree angle? Cosine. Sorry, yeah, 60, I'm sorry. So it's pi over 3, right? Pi over 3. Okay, so we know that's pi over 3. The cosine of x would be pi over 3. Where else is cosine positive? Quadrant 4, right? So when is it quadrant 4? 5 pi over 3, okay? So that is when the cosine of x equals pi over 3 and 5 pi over 3 equals 1/2, right? But what do you guys notice? We don't have just x now. We have what? 3x or 3t, right? So instead of saying x equals pi over 3, we're going to say 3t equals pi over 3, and 3t equals 5 pi over 3. You guys okay with that? Because normally we'd say x equals this, x equals that. But it's not x, it's 3t. So now, can you solve each of those? Yeah, can you solve for t? And how would I solve for t? Divide by 3, right? Divide by 3. So what is pi over 3 divided by 3? Pi over 9. And when is 5 pi over 3? What's 5 pi over 3 divided by 9? Or divided by 3? 5 pi over 9. Okay. Are you guys okay with that? Now, normally, okay, Did this give me an interval? No, so we need our general solution, right? So what do we add to these? What do we add to each of these? 2 pi over, or 2n pi, right? However, this isn't just cosine of x, is it? Or cosine of t. What do we have to do? We had to divide by 3, right? So guess what? We have to divide our general form also by 3. Now, if we multiply by 3, then I'd multiply each one of these by 3, right? But because I had to do this dividing by 3, our general form also has to be divided by 3. Okay, does that make sense to you guys? So originally, we could have wrote it like this. We know 3t equals that pi over 3 plus 2n pi, or 2 pi n. And then what would we have to do? Divide by 3. So I have to make sure I divide everything by 3. Okay. Sorry, you guys can't see that. All right, so 3 tangent of x over 2 plus 3 equals 0. Can you guys solve for the tangent of x over 2? So how would I solve for tangent in this one? And I subtract the 3. So I get 3 tangent of x over 2 equals negative 3. How do I get rid of that 3? Divide, so we get the tangent of x over 2 equals negative 1, right? So when is my tangent negative 1? When is my tangent negative 1? When is my tangent negative 1? So are we looking at 30, 60, 90 or 45, 45? 45, 45, right? Because, so we'd be looking at pi over 4. However, when is my tangent negative? In quadrant 2, right? Right, quadrant 2 and quadrant 3. However, what is our interval for pi, or tangent? It's between 0 and pi, right? So can we use quadrant 3? No, we can only use quadrant 2, right? So wouldn't that just be 3 pi over 4? Does that make sense to you guys? Because we know it's 30, 60, or 45, 45, 90, so it's pi over 4, but we need to turn it into quadrant 2. So we took pi minus that pi over 4. Okay. Now, that would be when the tangent of x equals this, right? Tangent of x equals 3 pi over 4, right? However, or x equals pi over 4. We actually have what? X over 2 equals 3 pi over 4, right? So what would I have to do to solve for x now? Multiply by 2. So we know x is actually going to equal what? 3 pi over 2, okay? Now, that would be in between our interval, right? Or obviously it's not in this case, but looking at this. Now, from this, we have to add on our general form, right? Our general solution form is usually n pi, right? But what did I have to do to this? I had to multiply by 2, so I need to multiply that by 2. So I would add 2n pi to that, and that would be my solution. Any questions about that? All right, using inverse functions. Now we're going to look at inverse functions. Do you remember our inverse functions where we just use the arctan or the arc cosine, that kind of stuff? Okay. Now, if you look at this problem, secant squared and tangent, those are two different trig functions. So we need to have one trig function in there. Can we turn secant squared to something tangent or tangent to something secant? So look at your trig identities. Can I change secant squared to something tangent or the tangent to something secant? Get your Pythagorean identities. Yes, secant squared equals 1 plus tangent squared. So if you have 5.1 nodes, those are the best ones to have out in front of you all the time, right? Okay. Now, can we go ahead and combine like terms and get everything on one side? Yeah. Obviously, tangent square can't be combined with anything. Same thing with tangent, but I can bring this 4 over, right? And how would I bring this 4 over? Subtract it. And what's 1 minus 4? -3 equals 0 now. And why did I put the 3 at the end? So that I'm in standard form, right? And if I'm in standard form, what can I do from that? I can factor it, right? So go ahead and factor. I'll give you a chance. Go ahead and factor that one on your own. What did you guys get when you factor? Tangent x in the first terms. And then what do we have? -3 and +1, right? All right. Now, once we have it factored, what do we do? Set each group equal to 0 and solve. So what's my first one? Tangent of x equals 3. And then the tangent of x equals -1. Right. So right now, we're going to look at our inverse. We know with tangent, we want to be in between 0 and pi, but usually our period is pi, right? If we think of our normal tangent curve, we're in between -pi/2 and +pi/2, right? You guys okay with that? Okay. So now, if I look at the tangent of -1, that normally would say we're in the quadrant of what? It could be quadrant 2, it could be in quadrant 4, right? It could be either one of those, right? So what we're going to do on this one, actually, because we want it in between -pi/2 and pi/2, that is quadrant what? 2 and 4. But what we're going to do is we're going to go ahead and just use the inverses for this one. Okay? Do you guys remember how to find the inverses of things? How do we get rid of the tangent? So we're going to work with our inverse. We have, how do I get rid of the tangent? Can't I just take the inverse of tangent? What's the arctan of tangent? Isn't that just x? Yep. Equals, and then we have to do it the same arctan of 3, right? Now, do we know what the tangent, do we actually know what the tangent of what was got me to 3? Do we have a 30, 60, 90 triangle? Did we have 45, 45, 90 triangle? No. So that's the reason why I went ahead and used my inverse here. And we don't actually know that. So we're going to leave it as the arctan of 3. Because if you actually use your calculator, it's like, I think it said it was 71 point something degrees. That's kind of crazy, isn't it? Okay. Now, let's go ahead and do it with -1. We can do this, right? Now, normally we would look at -1 and we would say it was 3 pi over 4, or it was 7 pi over 4, sorry, 7 pi over 4. But when you look at these, okay, that 7 pi over 4 is not between those two, is it? No. So go ahead and take the arctan of -1. Arctan of -1. And what do you guys get in your calculator? I think you get -45 degrees. But what is -45 degrees as in radians? -45 degrees is 7 pi over 4, right? So what's that reference angle? Isn't that just -pi over 4? It's just -pi over 4. Now, real quick, when I'm looking at this, and it's going to tell you to use inverse functions in the note, whichever ones they want. Now, one thing I want to look at, does it tell me what interval I actually want it to be in between? No, so I still need to do my general form. So what am I going to add to both of these? N times pi. And why is it n times pi and not 2n pi? Because it's tangent. Wait, you can't even see that. Sorry. Find all the solutions for sine squared x minus 3 sine x minus 2. That's our last one here. Okay. First thing, I would try to factor. Can I factor this one? What times what is -2 that adds to be -3? -2 times -1. -2 times 1 would add to -1. Nothing. I can't factor this. No, that's fine. But it also says in my directions to use quadratic formula. But so if I can't factor it, I have to use the quadratic formula. Do you guys remember the quadratic formula? So in this case, it's going to be sine x, not just x. What is the quadratic formula? There you go. Perfect. So let's plug it in. So this is going to be sine x. Okay, we don't have to worry about the signs. We're looking at the coefficients. What's my b? What's my b here? -3. So a negative and a negative make a positive. What's my b? -3. What's -3 squared? 9. Minus 4 times a. What's my a? 1 times my b, or my c, sorry, -2. Over 2 times what's my a? All right. So we have 3 plus or minus the square root of 9. What's a -4 times a -2? +8. Good. Over 2 times 1. 2. So we get sine of x equals 3 plus or minus what? Square root of 17 over 2. Can I simplify the square root of 17? No. All right. So let's go ahead and tell me in decimal form, what is 3 plus the square root of 17 over 2? And 3 minus the square root of 17 over 2. So tell me, do the plus sign first. 3 plus the square root of 17. What'd you get, 8? Okay, hit the double arrows at the bottom of your thing, right above the enter. 3.56. You did. I think you forgot parentheses in the top. Because if you didn't put the parentheses in the numerator, you're going to divide square root of 17 divided by 2 and then add the 3. So always make sure you have parentheses around the numerator. Or if you use your fraction key, the n over d. Okay. What did you get for the minus sign now? Negative 0.56, something like that, right? Good enough. Think of your sine curve. Think of your sine curve. What is my amplitude? What is the range of a regular sine curve? What is my amplitude? What is my max and my min? It'd be 1, right? So we know my range is between -1 and 1, right? So it's saying sine of x usually equals y, right? So this is really my y values here, right? Is there any one of these that would not work? The 3.56. So really the sine of x can only equal 3 minus the square root of 17 over 2, right? Does that make sense to you guys? Okay. So now, can we actually figure out my angle, what x equals? Do we remember how to get rid of the sine? How do we get rid of the sine? Take the inverse, right? So x would equal the inverse, so arc sine of the 3 minus radical 17 over 2, right? Okay. Helps if I remember to put the parentheses as well. And what do you guys get? Negative 34. Do you think that's going to be really nice? No. Okay. So once we know we have this, we're good in this sense here. Okay. Because we know it can't be the plus sign. We know it's just the minus. So that would be our exact answer there, right? Okay. Now, as I'm looking at this, think about this for a second. We know it's going to be negative 0.56, right? When is my sign negative again? In what quadrants? 3 and 4, right? So we know our sign is going to be negative in quadrant 3 or 4, right? So in quadrant 3, wouldn't I take pi plus whatever this is? So pi plus 3 minus radical 17 over 2. And in quadrant 4, how do I get quadrant 4? How would I get quadrant 4? What would be the easiest way? So 2 pi, would I add this or subtract this? I would subtract it. Why would I subtract? Because that's what you're missing, right? So these are your actual solutions from that. Okay, so you're kind of subtracting off that 34 point, or that point, what was it? Negative 0.56 and so on. Okay. Which I'm not going to turn those to decimals. That's kind of crazy. Okay. All right. Any questions?